In this video, we're actually going to be tackling the problem of how do we actually find um, the nth to last node. One thing we actually do need to take into consideration is some sort of integer, which refers to how far away the node should be from the very ending node. So what I should do here is I should say param n, the nth position from the end of the list. Okay, so let's actually draw this out and take a look and see what that looks like. So hopefully I'm not going to butcher these numbers. Let's say that I have a linked list that contains just a set of integers here. As we see, I have 1, 2, 3, 5, and 7. So is there anything important about this sequence of numbers? In this case, no, not really. So let's say that for the nth to last, I want to get the third element that is from the last of this. So what do I want to do? I want to start counting. So from the very end, this is the 0th distance from the last node. This one here happens to be 1 distance from the last node. This is 2. And this one happens to have a distance of 3 from the very last node. Now, the way you can implement this really depends on how you view the nth to last node problem. This is kind of how I view it, because this is the third node, which happens to be away from this. Now, if you decided to say that the last node happens to count as, say, first from the very, very, very end of, say, the null list here, then you could do it that way. In this case, 3 would be the number you're looking for. But in this case, I'm going to assume that I want to get the 2 here. So let's actually undo the sketches here a little bit. Okay, so n equals 3. How exactly am I going to do this? Well, fortunately, there is a little shortcut we can use here. So we do have a couple of special cases. One of the special cases is, what if n happens to be greater than our list? Well, then in that case, we're not actually going to be printing anything off. Our method should actually take that in consideration, and it will as we go through it. So let's ignore that case for now. One of the special cases, so I'm going to say, let me actually just type this up. So, okay, let's take a look at this. Okay, so what are the special cases? Well, what if we have a null list? Well, if we have a null list, then what we should do is we should just kind of return null, because we've got nothing going on. What happens if they give us an n which happens to be like, say, 0? Well, in that case, we just want to return null because we can't actually get the 0th. Well, we could get the 0th from the last, I guess, in the way I drew it. But in this case, we're going to assume that we can just return null. You know what? No, it's totally fine. We'll just say special cases where if the list is null or n happens to be less than, say, 0, then in this case we just want to return null, because we're not going to move forward to the end of the end. We're not going to move forward from the end of our list. That just wouldn't make any sense. So the question is now, sorry, how do we go about finding this value of 2? Well, what we need to do is we need to first be able to find the very end of the list, and then from here we could somewhat backtrack. Now, there is a big problem with that. That's a little bit redundant. Or not redundant, but it's a little bit tedious as far as things go. So, one thing we could do is, let's say that we have 2 pointers. We say this is our first pointer and this is our second pointer. And let's assume that our second pointer is going to traverse through our list up until we've reached a distance of n. So in this case, our pointer 2 will travel, say, 1, 2, 3. Okay, and what do we know at this point? Well, we happen to know that if we have pointer 1 pointing here right before the list, then we have, say, a distance of 3. So what I'm going to do is I'm going to eventually get rid of this. In the way that I've presented this beforehand, we actually need our pointer to travel, say, from here. Let's see. We need our pointer to travel, say, from here, then to here, then to here, then to here. So we need it to travel all the way there to get the appropriate behavior that I'm looking for. The reason why is we're going to assume that pointer 1 and pointer 2 initially start at the very front of the list. So going through this once again, pointer 2 is going to move n distance away from pointer 1 or from the very front here. So it's going to move 1, 2, and 3. Now the idea is that once pointer 2 is n away from pointer 1, we're going to keep progressing both of the pointers of pointers 2 and pointer 1 to the next nodes as long as pointer 2 happens to be valid and is not null. So let's actually implement this. So in the nth to last, we're going to say if, let's say if front is equal to null, where we have a just a null list, or n happens to be a negative number, what we just want to do here is just kind of return null because we've got nothing else to do. Otherwise, what we're doing is we're creating a P1 of the type T, so P1 and P2. Okay, so we know that we want to run a distance of n from the very front of our list. So what we can do is we can use a for loop which says while I is equal to 0 and I happens to be, let's say, less than n, which will allow us to run 3 from the very front. We just want to increment I by 1. Oops. What I need to do is I need to say P1 is equal to the front, and P2 is also equal to, say, P1 at this point. Okay. So in this for loop, once again, P2 is going to be equal to P2.getNext. And it's going to keep going up until it reaches the very end of the list. Now what we're going to do is we're going to create this while loop which says, okay, now that we've got P2 in the correct position, we'll say while P2 is not equal to null, because P2 is going to run to the end of the list first before P1, we'll say P1 is equal to P1.getNext, and then we'll say P2 is equal to P2.getNext. And then after, once P2 becomes null, we've reached kind of the end of the list here. And we've now successfully gotten the nth distance from the very last node, which would happen to be P1. If we return P2, we're going to be returning null, which would kind of be really sad because it would be very much like this case up here. So we return P1. So in order to check that this works, I'm going to create the list. Let's see, and the list in this case is not going to be a list of strings, it's going to be a list of integers. And we can actually ignore the type there. So let me shift things over a little bit. Okay, so shift all those with the exception of this one. Oops. With the exception of this. Okay. So we don't want to remove duplicates. In this case, we want to say list.nthFromLast, and we wanted to pass in 3. So list.append, we wanted to do append 1. I believe it was 1, 2, 3, 5, and 7. Okay, so we're going to save that all, and we're going to compile it. Oops. There we go. Okay. .nthFromLast. Return type is, oh, yeah. So what we need to do is we need to say my node t, or my node integer temp is equal to whatever it returns here. We're not going to print out the list. We're going to print out temp.toString. Okay. Let's take a look at this. Let's see, what errors do we have here? Cannot find symbol nth from last. Nth to last. Let's change this. Nth from last. Okay. Did we get any more errors? Nope. Okay, so now let's actually run this. Okay. So we got 1, 2, 3, 5, 7. So right now what we're doing is we're getting we're actually getting um, the location of this node, which isn't really helpful to us because in this case I can't actually tell what that is. So instead of saying toString, I'm going to use my own getData method. So let's actually compile this one more time, run it. Okay, there we go. Let's actually take a look to see if that's what we originally wanted in our method here. So n equals 3, we wanted it to point to the 2. The reason why it's not pointing to the 2 here is because in the last iteration we're actually moving both P1 and P2 over to the right one more time. So if we actually wanted to get the appropriate behavior, we could actually modify this while loop here and say while P2 get next is not equal to null, we'll keep progressing. So let's take a look and see how that affects our program. So there we go. Now we get the appropriate value that we were expecting. And yeah, that looks pretty good as far as things go. So some people might say that the very end of the list is right after the 7 here. I like to say that the very end of the list is this 7. So spaces 3 away from 7 would be 2. So that gives us the appropriate behavior. And I hope you guys found this useful.